Year 7, welcome back to another term where we're going to keep exploring fractions. When it comes to fractions, often, like these examples show, we want to work out which is larger or which is smaller. It's called ordering fractions. What order do they go in from smallest to largest? So to do this, the best way to do it is first of all, convert them to have the same denominator. That is the same number on the bottom. So if I look at these two fractions here, I can't compare them yet. I'm sure I'll get it wrong. But if I make the base number, the denominator, the same, I can then look at which number is larger on top. That's the idea. Let me show you with an example, with this example here. So question 1 asks us which is larger, 4/10 or 3/8. And as I said, I want to get the bottom number, the denominator, to be the same. However, there's two ways to do it. Like a lot of things in life, there's always two ways, and that's good. Okay, the first way, which is really straightforward. All you do is multiply the two base numbers. So I do 10 times 8. Who can tell me very quickly what's 10 times 8? If you're telling me your name, but the answer is, you're right, 80. So I'm going to have 80 on my bottom, my denominator. Now, with this fraction, I've multiplied by 8 to get to 80. So I must do the same to the top. What is 4 times 8? 32. Thank you. Please give me hope. Okay, 32 over 80. This one's a bit easier. You're multiplying by 10. What is 3 times 10? 30. Thank you. Now we can actually see which one is larger. Well, it's actually 32 over 80, or 4 over 10 is actually the larger fraction. So, the answer for this one, 32 over... Oh, sorry, let me actually write it slightly differently. The answer for this one is, therefore, 4 over 10 is larger. That's that first one. What about question 2? It's asking which is smaller. But I've made it a bit more complicated. Notice how this time it's got mixed numerals. So, first, we're going to need to convert them so that they're improper fractions. Who can tell me how do we convert 1 2/3 to be an improper fraction? Do you remember what to do? There's a process. Who remembers what to do? Yeah?
So 3 is your number?
Yes.
So 3 you can put away because that's your denominator?
Yep, definitely. So it's over 3.
Do you do 3 times 2?
Yes. No. Sorry, try again. 3 times?
3 times 3. 1.
Plus?
2.
Which is?
3. Oh, 5.
Yep, good work. So we've got 5 over 3. And same process again. We do 1 times 9, which is 9, plus 5 is 14. So we've got 14 over 9. Now the second method you can use with these sorts of questions, Year 7, is to actually look at what's the lowest common denominator. So what number do both 3 and 9 go into? I'll give you a hint. I'm pointing my finger at it at the moment. What do 3 and 9 both go into? 9. Try a bit lower. 9. Because 3 times 3 is 9. So if I can actually get this fraction to have a denominator of 9, I can then compare the top numbers. So let's do that. We'll put them both over 9. This one is already worked out for me. It's less work then. I already know that's 14. This one I need to work out. So what do I multiply 3 by to get to 9?
4. 3.
Thank you. So I've got to multiply both top and bottom by 3. So I actually get 15 over 9. So what's my answer to this question? Be careful, because notice what the question is asking. Yeah, which one?
Is it that one?
Yeah, it is that one.
14 over 9.
Yep. So it leads to, my answer is 14 over 9. Year 7, with this I've just shown you the two methods you could use. One is just to multiply the two base numbers, the two denominators together, all right, and make sure you have equivalent fractions. The second method is find the lowest common denominator, okay, or lowest common multiple, which in this case is 9. So you don't need to do anything here. All you need to do is find the equivalent fraction over 9 for 5 over 3. I have a question.
Why do you keep on drawing sideways smiley face under the answer?
It logically implies is the actual symbol. I'm not quite using it correctly, all right? But what I'm saying is the answer to this question is 14 over 9, or in this case, that one and that one. There are our two answers, just to make that super clear. We've got one more question. The last question is show the above numbers on a number line. Now the reason I've put this question here is because that will help us hopefully see visually how these are different. So first, always take out my ruler. All right, I've got my ruler here. If I was to draw a number line, I'll just draw it down underneath so we can hopefully see what's going on. Let's draw my number line with my ruler. Unfortunately, it moved on my page for me. All right, we start at 0. In this case, I don't need to go up more than 2. So I'll put the upper number at 2, which means about halfway along is my 1. If I was to draw my first two numbers, 4/10, what that actually means is divide this part up into 10 parts. All right? So there's 5. I'm just going to estimate roughly how far apart they need to be. You would use a ruler and measure it properly. But if I was going to do 4/10, that's there. All right? What I've actually learnt, 4/10, right, which is this one, is slightly more than 3/8. So in fact, 3/8 is just before that. This is not quite to scale, but I want you to be able to see that 4/10 is actually bigger. We can see that now graphically. What about the other two numbers? What we've actually got for the other two, I'm going to divide it up into 9 parts. They're both more than 1. All right? So I've divided that up into 9 parts now. I've got 14 over 9, so that would be 9, 10, 11, 12, 13, 14. That one there is 14 over 9. Okay? And my other one is 15 over 9, which is the next number up. So what you can actually see is that 4 over 10 is more than 3 over 8, if I draw this really accurately. 14 over 9 is less than 15 over 9. Now 14 over 9, the 15 over 9 we actually know was 5 over 3. So you could actually just write 5 over 3 there and it would be the same thing.
Shouldn't 15 over 9 be higher? Is it a higher number?
Yes, that's correct. But we were looking for which is smaller in the question. Remember that too. All right? So you can hopefully see graphically as well which number is larger and which number is smaller. All right. This is a bit of work, Year 7. I reckon we need to practice this. Starts with that understanding of how to find equivalent fractions and then work out what's in order. But if you're going to do it, get your denominator the same number. Let's get to work.